Okay, we have here a pretty tricky looking integral on the board. I've got the integral from 0 to pi over 2 sine 2023x times cosine cubed x dx. And the main problem I have here, I guess, is this large power on the sine. Although it might not be too bad. What I'm going to do actually for this one, I want to do this using two methods. And my first method is going to be kind of my favorite method, which is the beta function. Okay, we have here our formula for the beta function. You may know there's actually multiple formulas we could use, and I chose this one just because of the similarity with the sine and cosine. This is going to match up nice. But one thing I want to notice is this 2 in front, we don't have this on our integral. So what I'm going to do is actually let's just divide off that 2 and we'll have a 1/2 on the right side just to make this a little more usable for us. And what this is going to allow us to do is calculate our solution in terms of the gamma function. I just need to find my z1 and z2 value. And what we'll do for that is I'm just going to equate this thing to my exponent 2023, and I can equate this to our exponent here, which is 3. So this first one I can just set 2z1 minus 1 equal to 2023. And then solving for z1, I'm just going to have 1012. And then doing the same thing over here for our cosine, we're going to have 2z2 minus 1 equals 3. Well, then solving for z2, we're going to have this is going to be just equal to 2. So then going right to our formula over here, we still have our half out front, gamma of z1. So we're going to have gamma of 1012. Then for our 2, we're going to have gamma of 2 here. And then the denominator, we just have the sum of these two. So we're going to have gamma of 1114, I think. And then in order to simplify this, what I can do is I can calculate my gamma function in terms of the factorial. So we have this equation for that we could say gamma of n is going to be equal to n minus 1 factorial. So using that over here, we'll keep our 1/2 out front. So gamma of 1012 is going to be just 1 less, or 1011 factorial. Gamma of 2 is going to be 1 less. That's just 1 factorial. And this thing is going to be 1013 factorial. Well, 1 factorial is just 1, so we'll get rid of that. We're not worried about that. For 1013 factorial, I can expand this out a little bit and write it as 1013 times 1012 times 1011 factorial, but then I can cancel this one with this one. And so for our solution, we're just going to have 1 over 2 times 1013 times 1012. And so our solution is just going to be 1 over 2,050,312. Okay, so now moving on to method number 2. Okay, now for my method number 2, we're going to do this. This is going to be very similar to if this was a smaller exponent, like very similar to if this was, say, sine to the 5th x times cosine cubed. Well, what I would do for that is I would just split out one cosine to set up a u substitution. So like, let me just kind of write it way over here to make this clear. And so just so I don't change it, I'm still going to have my cosine squared x here because cosine squared x times cosine is my cosine cubed. And then we'll keep our sine to the 2023x. For cosine squared x, I can actually write this as 1 minus sine squared x. And now we're in good shape for a u substitution. For my u, I'm just going to say that's going to be sine x. Take a derivative, du is going to be just cosine x dx. But we like that quite a bit because we have our du right here, cosine x dx. So I'll go ahead and we'll make this substitution. And so take pi over 2, plug it in here. Sine of pi over 2 is going to be just 1. Plugging in 0, sine at 0 is just going to be 0. Then here I'm going to have, this is going to become u to the 2023. This thing's going to become 1 minus u squared, and this thing's just du. At this point we could use beta function again, but I'm not going to do that to you. We're going to just distribute this in here. So let's multiply that out and see what we have. So this is going to become u to the 2023 minus u to the 2025. Then we can just integrate using the power rule. So this is going to give me u to the 2024 over 2024 minus u to the 2026 over 2026. And we just need to evaluate from 0 to 1. But notice the 0 terms are just going to be 0. So I just need to plug 1 into this thing. So all we need to do is simplify this, but we're going to have 1 over 2024 minus 1 over 2026. Then in order to simplify a little more, what I can do is get a common denominator. So this is going to end up being 2026 minus 2024. Just multiplying by 2026 over 2026 here. 2024 over 2024 here. So we end up with our denominator being 2024 times 2026. I can take this thing and I can just write it as 2 over 2024 times 2026. But if I cancel here and here, I end up with 1 over 1012. I can write 2026 as 2 times 1013, but that's exactly what we had on the previous board, and this number is just 1 over 2,050,312. Okay, good problem. Let me know which method you prefer, method 1 or method 2. We'll stop it there. Thanks so much for watching. Have a great day.